Welcome back, everybody, for another deep dive. This time we're looking into the ESA's Hera mission.
Uh-huh.
You know, the one that's going to tell us if we can actually deflect an asteroid.
Hmm.
But we're taking a bit of a different route today,
Oh,
focusing on the recent events that have me pretty excited.
yeah, Hera's Martian detour, right? You're talking about that flyby of Mars and the observations of Deimos?
Exactly. It seems like every time I check in on this mission, there's something new and amazing.
Yeah.
And like the fact that we got to see the far side of Deimos,
Right.
a side we've barely seen before,
Yeah.
that's just incredible.
It really is quite remarkable. And this flyby, it wasn't just for sightseeing. This was a crucial step in Hera's journey.
Okay, yeah, explain that because to me it seems like they added like a whole extra leg to this
Right.
already complicated trip.
It is a bit of a detour, but think of it like this. Imagine you're trying to throw a paper airplane across a large room. You could throw it directly at the target, but it might not have enough momentum to reach the other side.
Yeah.
Instead, you could use a fan to give it an extra boost.
Right.
That's essentially what Hera did with Mars.
Yeah.
It used the planet's gravity to slingshot itself towards Didymos, saving both time and fuel.
Oh, so instead of using its engines to power through space, it just got like a free speed boost from Mars's gravity.
Exactly.
That's ingenious.
It is a clever technique.
It's like using a ramp to gain momentum,
Mm-hmm.
like a skateboarder and a half pipe or something.
Precisely. And during this close encounter with Mars, Hera got within about 1,000 kilometers of Deimos, which allowed it to capture those images of the far side.
Yeah, Deimos is a bit of an enigma, isn't it? I mean, we're not even sure where it came from.
Right.
Is it a captured asteroid or a chunk of Mars itself blasted off in some ancient cosmic collision?
Yeah, both are valid possibilities.
Mhm.
And the data Hera gathered might help us unravel that mystery. But beyond just snapping photos, you see, this flyby was a chance for Hera to put its instruments to the test on a real target. You see, up until this point, most of the instrument calibration had been done near Earth.
So it was like a dress rehearsal before the main performance at Didymos.
Exactly.
I'm curious, what instruments are we talking about?
There are three main ones. First, there's the asteroid framing camera, which captures basic black and white images.
Okay.
Then there's Hyperscout H, which is particularly fascinating because it can see in colors beyond human vision.
Hold on. How does the camera see colors we can't?
It's actually quite straightforward. It's sensitive to a wider range of wavelengths of light than our eyes can perceive.
Okay.
By analyzing these wavelengths, we can determine the mineral composition of Deimos, revealing what kind of rocks make up this intriguing moon. And finally, there's the thermal infrared imager, which measures temperature.
So it's basically taking Deimos' temperature.
Yes, essentially.
What can that tell us?
Well, temperature readings can reveal a lot about surface properties like roughness and density. This data will not only help us understand Deimos better, but also inform other missions, such as JAXA's Martian Moons Exploration Mission, or MMX.
Oh, right. The mission that's aiming to land on Phobos and bring a sample back to Earth.
Yes.
But what does Deimos have to do with that?
Well, they are two different moons,
Right.
but scientists believe they may have similar origins. So studying Deimos could provide valuable insights into what we might expect when we visit Phobos.
I see.
Think of it as gathering intel before heading into uncharted territory.
Right. Yeah. I'm starting to see how all these pieces fit together. Hera's flyby of Mars was a brilliant maneuver, not only giving the spacecraft a speed boost, but also allowing for some incredible scientific observations of Deimos, which will inform future missions to the Martian system. It's like a cosmic domino effect.
Precisely. And all of this is building towards Hera's primary objective, reaching the Didymos system and studying the aftermath of NASA's DART impact.
Right, the big event where they purposely crashed a spacecraft into an asteroid.
Yes.
To see if we could nudge it off course. It's like a cosmic game of billiards with incredibly high stakes.
Indeed. This is the first time we've ever attempted something like this, and Hera's going to give us a front row seat to the results.
Yeah, it feels like we're on the verge of something truly groundbreaking.
We are, and the Deimos flyby has shown us that Hera is more than ready for the challenge.
Okay, before we get too ahead of ourselves, can we recap the timeline for our listeners?
Sure.
When did this Deimos flyby happen, and when will Hera reach Didymos?
The Deimos flyby occurred just recently on March 12th, 2025.
So fresh data.
Very fresh.
And Hera will reach Didymos.
In December 2027.
So a little over 2 years from now. It's amazing how these missions operate on such vast timescales.
It is. It's a testament to the meticulous planning and patience required for deep space exploration.
Speaking of patience, I think it's time for us to take a short break. But don't go anywhere, because when we come back, we'll be diving even deeper into the implications of Hera's mission and what it means for the future of humanity.
Sounds good. As we were discussing before, Hera's recent flyby of Deimos has provided a wealth of information and a unique opportunity to test the spacecraft's instruments.
Right, in preparation for its main objective.
Exactly.
It really is remarkable how much we've learned from this flyby, and we haven't even reached the Didymos system yet.
Yeah, it's just the beginning.
It's like getting a sneak peek into the future of space exploration.
It is a glimpse into the future, and it's a future where humanity is taking a more proactive role, in its own destiny, especially when it comes to potential threats from space.
Yeah, that leads perfectly into my next question. Hera's primary mission is to study the aftermath of NASA's DART impact on Dimorphos. It's the first time we've ever attempted to deflect an asteroid, and the implications are huge. What could this mean for the future of humanity
Right.
if we're successful?
It's a question that sparks both excitement and trepidation. On the one hand, the ability to deflect asteroids could provide a crucial defense against a threat that has impacted our planet countless times throughout history.
It's almost like taking control of our planet's fate, rather than simply hoping for the best.
Precisely, for millennia, we've been at the mercy of cosmic events. But now we have the potential to safeguard our planet from these potentially catastrophic impacts.
Yeah, it's a huge step forward for humanity. But with any new technology, especially one with this much power, there are bound to be ethical considerations.
Absolutely. The ability to manipulate celestial bodies raises complex questions about responsibility control and potential misuse.
Right, like who gets to decide which asteroids we deflect?
Exactly.
What if the technology falls into the wrong hands?
Precisely, these are not simple questions, and they require careful consideration as we venture further into this uncharted territory.
It's like opening Pandora's box. We're unlocking incredible potential, but we also need to be mindful of the potential consequences.
A very apt analogy. It's crucial that as we develop these technologies, we engage in open and honest discussions about the ethical implications, ensuring that our advancements serve the best interests of humanity as a whole.
And it's not just about planetary defense, is it? There's also the potential for resource extraction from asteroids. We've been hearing about companies interested in mining asteroids for precious metals and other valuable resources.
Indeed, if we can deflect asteroids, we can potentially redirect them closer to Earth for easier access to their resources. Imagine a future where we're not just mining our own planet, but harnessing the resources of space to build and sustain our civilization.
It's a tantalizing prospect, but also a bit daunting. Mining asteroids raises its own set of ethical considerations, such as environmental impacts and questions of ownership. It seems like we're standing at the precipice of a new era, one where our relationship with space is about to change dramatically.
We are at a turning point, and missions like Hera are paving the way for this new era by providing us with the knowledge and understanding we need to navigate these complex challenges.
I find it incredibly inspiring that we're even having these conversations. It shows how far we've come in our understanding of the universe and our place within it.
It's a testament to the human spirit of exploration and our insatiable curiosity to unravel the mysteries of the cosmos. And as we continue to push the boundaries of what's possible, it's crucial that we approach these advancements with a sense of responsibility and a commitment to using them for the betterment of all humankind.
Okay, before we dive even deeper into the ethical and philosophical implications of asteroid deflection and resource extraction, let's circle back to the Hera mission itself. You mentioned earlier that the Deimos flyby was a valuable test run for Hera's instruments. Can you elaborate on that? What specific challenges might those instruments face when they finally reach Didymos?
Certainly one of the biggest challenges for Hera's instruments at Didymos will be operating in a low-gravity environment. Unlike Earth, where gravity is relatively strong, the gravitational pull of Didymos and its moon Dimorphos is much weaker.
So how does that affect the instruments?
It can affect their stability and accuracy. Imagine trying to take a clear picture while standing on a trampoline. The bouncing and instability would make it difficult to focus. Similarly, Hera's instruments will need to compensate for the low gravity to ensure they capture accurate data.
That makes sense. It's amazing how even seemingly simple tasks become complex challenges in the realm of space exploration. Are there any other challenges they might encounter?
Another challenge is the potential for dust and debris surrounding the Didymos system.
Oh, right. Because DART deliberately crashed into Dimorphos, creating a cloud of debris.
Exactly. That debris field could pose a hazard to Hera's instruments, potentially obscuring their view or even causing damage.
So they'll need to navigate this debris field carefully while also dealing with the low-gravity environment.
Yes.
Sounds like quite the balancing act.
It is a delicate operation requiring precise maneuvering and a deep understanding of the dynamics of the Didymos system. But the Hera team has been meticulously preparing for these challenges, and I'm confident they'll be able to overcome them and gather valuable data from this unprecedented mission.
It's reassuring to know that they've thought of all these potential obstacles and have plans in place to mitigate them. It speaks to the incredible level of expertise and dedication involved in space exploration.
Indeed, and let's not forget the remarkable feat of international collaboration that this mission represents. We have scientists and engineers from all over the world working together to make this happen. It's a testament to our shared curiosity and our collective pursuit of knowledge.
It's a beautiful example of what humanity can achieve when we work together towards a common goal. This Deimos flyby has provided a wealth of information and a unique opportunity to test the spacecraft's instruments in preparation for its main objective at Didymos. But it's clear that the Hera mission is about so much more than just studying asteroids. It's about pushing the boundaries of human ingenuity, expanding our understanding of the universe, and ultimately securing our place within it.
Beautifully articulated, the Hera mission is a microcosm of the human spirit, our drive to explore, to understand, and to overcome challenges.
This conversation has been incredibly insightful, and I feel like we've only just scratched the surface of the implications of this mission. I'm eager to see what new discoveries and challenges await Hera as it continues its journey towards Didymos.
As am I, the Hera mission is a testament to the power of human curiosity and our collective pursuit of knowledge. And as we continue to push the boundaries of what's possible, I'm confident that the next chapter in this incredible story will be even more captivating.
We've been talking about the Hera mission, its flyby of Deimos, and the upcoming rendezvous with Didymos. But before we wrap up, I want to dive a little deeper into something we touched on earlier, the idea of asteroid mining.
It's a topic that really captures the imagination, doesn't it? The idea of venturing into space to harvest the resources of asteroids feels like something straight out of science fiction.
It really does, and it's not just fantasy anymore. We know that asteroids contain vast amounts of valuable materials, things like precious metals, water, even platinum.
Right, and accessing these resources could have a profound impact on our future, potentially alleviating resource scarcity on Earth and fueling further exploration of space.
Yeah, it sounds like a win-win situation. But I'm wondering, are there any downsides to asteroid mining? What kind of environmental impact could it have?
That's a crucial question. While asteroid mining offers some really exciting possibilities, it's essential to approach it with a sense of responsibility and sustainability. We need to carefully consider the potential environmental consequences, both on the asteroids themselves and on the surrounding space environment.
So things like debris from mining operations,
Yeah.
or disrupting the natural orbits of asteroids.
Precisely. We need to develop technologies and protocols that minimize these risks, ensuring that our pursuit of resources doesn't create unintended consequences that could harm the delicate balance of space.
It sounds like there's a lot to consider before we start digging into asteroids. It's not just about the technological challenges, but also the ethical and environmental implications.
You're absolutely right. As with any new frontier, we need to proceed with caution and foresight. The Hera mission is a prime example of this. It's not just about deflecting asteroids, it's about understanding them, their composition, their behavior, and their role in the larger cosmic ecosystem.
It seems like the more we learn about space, the more we realize how interconnected everything is.
Precisely. And that interconnectedness underscores the need for collaboration and responsible stewardship. The Hera mission is a testament to international cooperation with scientists and engineers from around the world working together to advance our understanding of asteroids and our ability to interact with them safely and sustainably.
It's inspiring to see what humanity can achieve when we pool our resources and expertise. And it gives me hope that we can navigate the complex challenges of asteroid mining in a way that benefits all of humanity, not just a select few.
That's a crucial point. The potential benefits of asteroid mining should be shared equitably, ensuring that it contributes to a more sustainable and prosperous future for all.
It's a lot to think about. But these are the kinds of conversations we need to have as we venture further into space and begin to harness its resources. The Hera mission is not only pushing the boundaries of scientific exploration, but also challenging us to consider the ethical and societal implications of our actions.
And that, I believe, is one of the most profound legacies of space exploration. It not only expands our knowledge of the universe, but also compels us to reflect on our place within it and our responsibility to safeguard its future.
It's a humbling thought, isn't it? That by studying distant asteroids, we're also learning more about ourselves, our values, and our interconnectedness with the cosmos.
Indeed, the Hera mission is a testament to human ingenuity and our insatiable thirst for knowledge. But it also serves as a reminder that with great power comes great responsibility. As we continue to explore and potentially exploit the resources of space, we must do so with wisdom, foresight, and a deep commitment to the well-being of our planet and all its inhabitants.
Well said. That's a perfect note to end on. Listeners, we hope you've enjoyed this deep dive into the Hera mission and the exciting possibilities and challenges of asteroid exploration and potential resource extraction.
Until next time, keep those minds curious and never stop exploring the wonders of the universe.
And remember, the future of space is in our hands. Let's make sure we shape it wisely. This has been The Deep Dive.